Bismillahirrahmanirrahim. Welcome students. Today we will do article 2.7 motion of freely falling bodies. In today's lecture we will discuss about free fall motion and the effect of G, that is gravity, on it, how kinematical equations can be changed in case of free fall motion, and we will also solve one or two problems related to freely falling bodies using 10 meter per second square as value of G. So, what is free fall motion? It is the motion of an object under the effect of gravitational force only. These are the examples: motion of a skydiver, motion of a bungee jumper. But free fall doesn't mean that the object is falling down only. Objects thrown vertically upward or downward, and those released from height are all examples of free fall. I really like this picture. So, wouldn't an elephant fall faster than a feather? And you know what Aristotle thought, and in late 16th century, even people believed that heavier objects fall faster than lighter ones. However, then Galileo came in and he said that no, two objects would fall at the same rate regardless of their mass. And he was the first scientist to notice that all the freely falling objects have same acceleration independent of their masses. And he dropped various objects of different masses from the Leaning Tower of Pisa. He found that all of them reached the ground at the same time. So, if we are considering free fall, the object moves under sole influence of gravity, and objects that free fall do not encounter air resistance. Hence, all objects fall freely at the same rate of acceleration regardless of their mass. So also objects drop near the surface of the earth, they do fall with same constant acceleration, that is value of G is same. That is why a feather and an elephant will fall at the same rate if dropped. So the characteristics of free fall, they do not encounter air resistance. They are falling so fastly under the influence of gravity, they don't even feel the air resistance. And all the freely falling objects accelerate downward at the rate of 10 meter per second square. This is the constant value of G at the surface of the Earth. Yeah, and acceleration due to gravity is denoted by the symbol small g. You can't use capital G, that is for gravitational constant that you will be learning in later on chapters. You have to be very specific in using the symbols. So, when a ball is thrown upward and downward in air, what is the value of G going to be? And that is the thing that we have to see. So, what is acceleration due to gravity? Firstly, you have to know about it. Acceleration of freely falling bodies is called gravitational acceleration. It is denoted by small letter g. It is positive for downward motion, vertically downward motion, and it's taken negative for upward motion. Yeah, and its value on surface of the earth is 10 meter per second square. Now, acceleration, we have already learned in previous lectures that the formula for acceleration is change in velocity by time, and we are saying that the body, when it's in free fall motion, its value is constant, that is 10 meter per second square. Yeah, so A over here gets changed to G. So its G is equal to V by T. So the value is constant. It means it's 10 meter per second. So it means that each second, during each second, the velocity of this ball over here, this ball over here, the velocity of this ball changes by 10 meter per second. Its velocity increases by 10 meter per second or decreases by 10 meter per second every second. This is the change that you observe when the body is in free fall. So velocity, it means changes. However, value of g, it's a constant value. It does not change. Yeah. However, the sign convention. So yeah. So the change in speed is due to g. It means that if the object is moving down, it's speeding up, and if the object is moving up, it's slowing down. And since you take this value of g as positive because the object, this ball, is moving towards the Earth's gravity. That is why you're taking its value as plus 10. And over here, you're taking a minus sign with the value because it is moving against gravity. Yeah, its motion is against gravity. That is why there is a negative sign to it. Now you have to keep that in mind when you're solving the numericals too. So what is the direction of acceleration and velocity going to be? When bodies are thrown upward in air, the ball's velocity is upward initially, since gravity pulls object towards the earth with constant acceleration g, and you know the value now, it's 10 meter per second square. So the magnitude of velocity will decrease. Yeah, it does decrease as ball approaches maximum height. If you see a value of v, it will change. However, g value will remain the same, that is 10. However, the directions, if you notice the direction, velocity of the ball is in direction of velocity of the ball is in upward direction. However, g will be pointing towards the earth. Yeah. And then at maximum height, momentarily, the velocity of ball is zero. Velocity of the ball momentarily at this point is zero. However, g is a constant value. It's 10 meter per second square. It does not change, and the direction of g is again pointing in downward direction because Earth's gravity is attracting every object towards it. That is why g, the direction of g throughout the ball's motion is going to be in downward direction. However, the direction of velocity and magnitude is going to change. Yeah. So during the downward motion, if you see from highest point to its, when it's traveling back, the ball has, obviously it's going to gain velocity. The magnitude of velocity will again increase as the ball is falling back to the earth. And now over here, v and g both are, the direction of both of these quantities are same, that is towards the earth. It is in downward direction. You have to keep v, g, their directions in mind, and value of g, whether it's going to be positive. If you see over here, since over here g, obviously the ball is moving in upward direction. Yeah, so you have to take the signs that we have discussed earlier, that it's going to be a negative sign because balls over here was moving upward. So value is going to be 10. However, it's going to be with a minus sign. And over here, it's coming towards the earth. So over here, its value is going to be plus 10 meter per second square. You have to consider the signs because then your numericals will be wrong. Your problem solving, obviously, you have to see the signs as well. Okay, this is how your kinematical equations change. They are also the kinematical equations of motions are also responsible for free fall. And yes, because free fall is an example of uniformly accelerated motion. So these are the kinematical equations. Vf is equal to Vi plus At. You have derived these equations previously. S is equal to Vit plus half At square, and 2S is equal to Vf square minus Vi square. So when an object is falling freely, obviously then you take into consideration as G. Yeah, so you're in free fall motion, your kinematical equations change. What sort of changes are you going to see? A is replaced by G because in free fall, G value is constant. So A is equal to G, and distance over in horizontal motion, you do consider objects moving, traveling in a horizontal path covering some distance. But over here, since objects are thrown vertically upward or downward, so that is the height that you take. The distance over here is equal to height. So you will replace S is equal to H. So Vf is equal to Vi plus Gt, then H is equal to Vit plus half Gt square, and then 2Gh is equal to Vf square minus Vi square. Let's consider this example. A stone is dropped from a tower. Stone hits ground after 5 seconds. Find the height and find the velocity with which it hits the ground. Okay, initial velocity, we have time the stone took was 5 seconds. You have to find the height and then the initial velocity. H is equal to Vit plus half Gt square. That is what we are using. And then 2Gh is equal to Vi square minus Vi square. We simply just use the second equation of motion. Why are we not using third equation of motion? Because over here Vf and H both are unknown. That is why we are using the second one. So H is equal to 0 into 5 plus half into 10 into 5 square. You just simply solve it and the answer is 125 meter. And you find the final velocity. You can use the third equation now. 2 into 10 into 125 into Vf square minus 0, and you sort it out and the answer is 50 meter per second square. You have to write the result over here. So this is a pretty easy numerical. Let's see the other one. A boy throws a ball vertically up. Okay, it returns to the ground 5 seconds later. This is, let's suppose a boy is standing over here, is throwing a ball, and it returns to the ground 5 seconds later. This is the time. Find the maximum height. This is the height from here, from this point to this point. You have to find the height and then the velocity with which the ball is thrown up. That is the initial velocity. Initial velocity is question mark. Height is question mark because we don't know. But momentarily your ball does stop at a height. So we take V is equal to 0. And then since time is 5 seconds, this was the time that was given when the ball was thrown up and it reached the ground. So that was the total time, 5 seconds that was given to you. So you have to divide time into two portions. That is the upward journey and the downward journey. So 5 divided by 2 is going to be 2.5. It means 2.5 seconds upward and 2.5 seconds downward. That is how you are dividing the time. And you have to find the maximum height reached by the ball and the velocity with it. Okay, so acceleration due to gravity is taken as minus 10. Yes, of course, it's minus 10 because the ball is thrown vertically upward. You're finding the maximum height for it. Everything that you have to find is for the ball that is being thrown up till this portion. So yeah, actually you have to do all the calculations from this point till this point. And over here, value of G is 10, but with a negative sign. That is why minus 10 meter per second square is going against gravity. That is why a negative sign. Time for upward and downward motion, total time given was 5 seconds. Velocity at maximum height, final velocity obviously at maximum height is 0, initial velocity you have to find out and height. Using the formula, Vf is equal to Vi plus Gt and H is equal to Vit plus half Gt square. You have to write the solution to find initial velocity. 0 is equal to Vi, you are using this A equation, first equation. Yeah, Vi plus Gt. That is how you simply solve it. To find the height, half into G into T square. Yeah. Yeah, I forgot to put 2 square over here, but the calculations are correct because I did solve it with the calculator. Okay, so 62.5 minus 31.25 is equal to 31.25 meter. You should solve it and then definitely just let me know you did get the answer right or not. You have to discuss the result at the end. Okay, the summary of today's lecture. All objects falling near the surface of the earth accelerate at a constant rate of 10 meter per second square. I hope you all agree now. Value of G is constant near the surface of the earth. It means value of G is 10 near the surface of the earth. It can change with height. Yes, value of G does change with height. It decreases, and we will be discussing about the variation of G with altitude in your upcoming lectures, probably in chapter number 5. Yes, we will be discussing it in detail. The sign convention changes with the change in direction of object. Yes, it does. G, we use a negative sign with G when it is moving against, when the object is moving against gravity, and we take the value of G as positive when the object is moving towards gravity. G is equal to minus 10. Yeah, this is what it is written, moving vertically upward. G is equal to 10 if our body is moving vertically downward. You have to revise the lecture and you have to solve numerical 2.4 on page 54. I hope you did get the lecture today. It was pretty easy. We were talking about G, its values, velocity, direction, acceleration, everything. So, if you still have any problems, if you still have any queries, you can definitely contact me on my WhatsApp number. See you in next lecture. Next lecture. Okay. Take care. Allah Hafiz.